So obviously, welcome back. Hope your weekend's going well. A couple of things I want to talk a little bit about just from looking at everyone's work over the past week, which I really love seeing everyone share stuff in the Slack channel. So thank you for doing that. So a couple of things. One is obviously we found out that the memory we set for our servers on GCP was too low. That was a brain fart on my part because when I read 213, I thought it meant 2 times 13, which is like more of a hardware thing. It actually only meant 13 gigabytes, which is not enough for our machines. So if you haven't seen yet, in Slack, I posted a note about how to upgrade the memory on your machine. So that is basically you want to do, I think it's 26 or 50 or something like that. Pick one of those to work with. Usually the rule of thumb is that for however large your GPU is, so we're working with a 16 gigabyte GPU, you need at least that much of RAM or higher. And higher will generally be a little bit better. So that was obviously a mistake on my part. So hopefully it seems like people got that working out, which is great. Secondly, there was clearly something wrong with that 1280 wide by 768 high pickle file. So if you were trying to work off that and found issues, that's probably something wrong with that pickle file, not with your training. I think what happened there is, so even though I said you can transfer off any file, that file had really only been training for, I don't know, maybe a couple of days. And it also was training from scratch. And because I think that data set was mostly like visual noise and not really like actual sort of like structures or pictures or anything, I don't think it trained long enough or on the right things to really be able to transfer from. So I'm gonna hopefully work this week on a different video that will hopefully, or on a different data set to hopefully make a transferable file from that. The hack we found around it for the moment is either to train from scratch, which is cool, but like gonna be a little bit longer of a time for you, or to rotate all of your images instead of horizontal to vertical and then train off of one of the other vertical models. So that will, it's basically like you'll train it on a vertical model, and then when you do the inference and create videos, you'll like flip it back. So which is a little annoying, but it also will save you a lot of time and money in order to train stuff. So that's just one way to think about it. Again, sort of learning as we go along with all these classes. As I said, this whole class is pretty experimental. It's the first time I'm teaching this. And it's just sort of been, I'm learning a lot, which is great for me. And also like, hopefully not showing too many of the rough edges, although this week seemed a little bit like it. Trying to think if there's anything else to add from this week. No, I think that's it. Really great to see everybody's data sets and stuff. It seemed like there's some really cool stuff we're working on. And I hope we can see more over the next couple weeks. I'm really excited about this class, or today's class, because partly because I did a lot of work for it. I built in a couple more tools this week just so people can do new things directly in Colab, which I think will be really fun to see people play with. So we have a jam-packed class. We're going to do a lot of demoing today, which always tests the demo gods. And of course, this morning, or like 1 minute into our class, my internet went out. So we'll see, fingers crossed, that doesn't happen again as we're demoing stuff. If we don't make it to everything in this class, I'll just record some videos. And usually the videos are better anyway because I have a little bit more time to prep, or like aren't trying to do stuff live and can edit them. But we'll see how it goes. But I'm pretty excited because there's lots of stuff to cover in this class. So I'm just going to quickly share my screen here. So obviously where we are this week is we're going to look at, once you have a pickle file you're happy with, how do you start making new images, videos, other things from it. So we're going to play with a lot with sort of manipulating stuff. We're going to do a lot of stuff in Colab today, and I'll talk a little bit about what Colab is. Weeks 4 and 5. So next week we're going to look at some more advanced techniques, maybe a little bit of like audio reactive stuff. I know some people want to play with that model that plays with sliders and things. I'm going to try to get that set up. We'll see how it goes. There are some advanced techniques. So we'll see what we actually get to, but we'll definitely get a couple things in there. I think week 5, I'd really set up a show and tell, but like 5 weeks of instruction feels like a little bit more of the right way to go for this class. So I'm going to maybe make it a little like half of the class will be show and tell, and then we'll find some other advanced things to look at. I might try to do, Peter Bailey's has a fork of the StyleGAN model that allows you to do class labels. So I might try to demo that. We'll sort of see how that goes. And then this week I will be sending out an email that will let you sign up for like a 15 to 20 minute slot to talk to me or Leah, if you want to talk to Leah or me, or both of us. And we can schedule those times to do one-on-ones. So if you have a particular project you're working on, just want feedback, or if you have like questions about models or other things that you didn't want to ask in this forum or on Slack, like you can ask us there. This is what we're going to do this week. So we're going to do a little quick breakout session to have people discuss projects. It seems like it's been fun. We've been doing it more in some of our other classes, and it's a nice way for people to like sort of like talk to each other without feeling like they have to like, you know, talk to Lee or I directly. So hopefully that'll be fun. We're going to do a Colab overview. If you haven't messed with Colab before, we'll quickly get you set up to sort of start to work with that. And then we're going to talk a lot about latent spaces and generating images in latent spaces and making videos out of those and a bunch of other things all around latent spaces. So that'll be like pretty much the entirety of the class. And then we'll end with a little bit of a projection thing and might get to some advanced level stuff if we can. So we'll see. I'm going to have Leah kick it off.
Hey everybody, I'm gonna put you in some small groups of 3 to 4 to just kind of like share notes on what you found this past week and talk about like what you learned when training your StyleGAN model. I'm gonna go ahead and send you guys to breakout rooms now. Me and Derek might be jumping around and kind of popping in to listen in.
So any questions or just sort of like general consensus from the group about any questions you have or just sort of things you're learning or not learning?
I have a question. Each time a pickle file is being generated and there is a fake and an initial image, how does it, because we end up with this sort of grid, the matrix of images of input and output, at what point, like how do the images from the input get matched to each and every square? I don't know if I'm making sense, but
no, you are. Yeah. Yeah, so the way that those fakes work is those fakes are just they're sort of randomly generated when you first start the training, and what you're actually looking at is those same, so we'll talk about this today, but those same seeds iterating over time. So basically as a seed changes, so as like the top left image as you go through the fakes, that image is the same vector representation, and it's changing over time as it learns new things. I don't think it connects to in the same way that the initial images are, or like the what's called the reals. I don't think that there's any relationship between the real images and the fake images. It's just the fakes over time. They do sort of map, like you could like onion skin them and they would like, you could see them change over time. And then how those fakes are generated is it's sort of random, but like I've also like sort of, I actually like someone asked this in like a class in January and I never looked into it, but I do think there is some sort of, it's semi-random, but then there also are some like different interpolation or like different truncation values being passed through those as well. Yeah. Moises, do you want to go ahead and ask your question? Yeah, go ahead, Moises. Yeah, I think you're muted.
We were talking about the landscape mode, and I think you had suggested to train vertical for now.
Yeah. Yeah, I can just talk a little bit. So basically what that model is it's a model of very noisy images from like a different, it's from a pix-to-pix next screen prediction model. And basically what I think happened with that is, one, it was only trained for 2,000 ticks, which isn't really long enough for like, it was trained from scratch at that. So it's like a very like sort of early model. So I think it, one, just didn't learn enough representations to really be able to like transfer off of. And then two, I think because the model is these rather noisy abstract shapes, I don't think the model actually picked up enough to like really transfer to new materials. So I stopped the model and I tried to retrain off of it, and retraining, like basically picking up where I left off, also isn't working. So there's definitely something up with that model. Yeah, so, you know, last week I said, you can transfer off anything. And now this week I'm like, well, maybe not, which is just sort of as we learn about all these things. That's what I would say about that model. So the other one should work fine. Yeah. Okay. Go ahead.
So when you say ticks, what does that mean? Because I think of like batch or tick or
so StyleGAN doesn't have a model of doesn't have a concept of epochs. They have a concept of what's called a ticks or a K image. And a K image is 1,000 images that have been passed through the model. So a tick is every time, if you were to look at your no-hup logs, you would see every like 45 minutes or so, there is a new generated fake and a new generated pickle, and that is what's called a tick. Any other questions? Any other things that groups have been discussing? I know Anastasia, yeah, so go ahead. Go ahead, Espan.
So there's any way that you can count those ticks without going to the system and checking how many they are? There's any, do you have a command that we can use to pull out that information?
It's basically counting. So it's counting how many fake files you have, or if you know what it started at. So obviously, if you've trained multiple times, you might lose those numbers. But like, if you go back to the very beginning and see what the number started at, and then you like count up from there, that can sort of tell you how many K images you've done, and then you might be able to divide that by ticks, but it's a little tricky sometimes. Yeah.
Yeah, because sometimes I usually retrain them, so. Yeah. It's really hard to keep counting how many I did. So that's why I'm asking if there's any way to have like results out of the system to let you know how many you did or something.
No, not especially after you've finished training. There's no way to go back and find it. That's also why my numbers on many of my files are also very weird, because I've done similar things. Like I think Kynan and I were talking about how like some of those models that I said you can transfer off of, it looks like they've only trained for 2,000 K images, but realistically, it's probably way higher because I've like transferred them from other things and other things. So yeah, it's just like, it gets kind of messy. And also I'm just like not the most organized person. So like, it also gets very messy that way too.
Got it. So the other thing that I noticed is that the number of the pickle is not the same as the fake. So they don't match.
They should.
We don't match, like it is not the same. So when I'm trying to find like, when I pick up a fake that I like and I try to find the pickle that is.
Oh, yeah. Okay. So basically the way the model is set up by default is that you get 4 fakes before you get a pickle. So after 4 fakes, then it creates a pickle. So there will sometimes be fakes that do correspond to pickles, and then there will be fakes that don't. And this is something that Anastasia and Will and I think Kyle and I were talking about, which is like, you shouldn't pick a model purely based on the fake data you're seeing. Like that is like there's 20 images in that fake grid. And if you like one of them and you're like, this is the model I want to use, like that's not really the right way to think about it. Like, so in general, what I would say is if you find a fake you like, go to the next pickle from there. That exists from there. So like find the next one higher up. Because again, like you're looking at a 24 images or whatever, like representation of your model. That isn't a real representation of your model. It's just a couple samples out of it. And also I would generally say like, don't like, again, this is like what I described as like, don't watch the water boil. Like don't be like 2005 is better than 2008. It's like, not like, that's not like, they're so close to each other that it's like not worth really thinking about that. Now in early stages of those training where you're getting this sort of translations or transfers off of the other file, there is maybe some of that because it's so much is happening in that time. But once you get to a later stage, like say a day or 2 days after, like so many small little details are changing that it's not really like, you're going to kill yourself if you try to like overthink it and pick like between sessions that are really close to each other. So actually in my work after a day, like I usually let it run for like 24 hours before I check it again. And I only compare every day's worth of training because it's just really not, it's not worth it to like try to like differentiate between 2 little levels. The reason we produce all those fakes though is to make sure that we're not mode collapsing or to make sure we're not overfitting, because mode collapse happens really, really quickly. Mode collapse can happen in 4 to 8 ticks, like so really fast. So you don't want to like train for 12 hours and find out like, oh, I had a mode collapse that happened like 11 hours ago. That's why I sort of keep track of those things. Caitlin.
Have you ever seen like spontaneous recovery from mode collapse, because I got really worried about my model and it got really gross for a couple ticks and then kind of bounced out of it, and now it's looking great.
So Kynan and I were talking about this too, which is that this is a thing that happens. So the way these models learn is they almost take random guesses, right? They guess randomly in a certain direction, and then the discriminator can sort of say like, hey, wrong way, buddy, like move back. So a lot of times what you will see is like the models will go in a certain direction and then they'll kind of like revert backwards because it's sort of like it's learning as it goes. Especially early in the process, you'll find a lot more of that happens. And we'll actually talk about that today with projection too, because it happens in projection as well. Getting out of mode collapse is pretty rare, but it could happen. Because again, like mode collapse is actually more of where like the discriminator doesn't even know what it's looking at anymore. So, you know, as long as the discriminator stays like healthy, you're actually in a good place because that can train the generator to go out of it. Sometimes it happens, but it's pretty rare. But if it's happening in your case, good to know. And like, it is something that could happen. Yeah. Cool. Okay. Just for the sake of time, because I know we have a lot to cover today, I want to go and jump ahead and start working on this week's session. So if you have other questions, post them in Slack, post them in the chat, and Leah and I can take them after our break. Okay, so today we are going to look at Google Colab. If you haven't used Colab before, we'll do a quick demo and then we have a big example file to run through that we're going to use. So I like using Colab because for a couple reasons. One is that it's free, and two is that it's something you can spin up very quickly. So unlike these GCP servers that cost you a lot of money and sort of like are pain in the ass to get working, Colab is really easy. Colab, if you've ever worked with Jupyter Notebooks before, it's based on that. So basically, we'll talk a little bit about what notebooks are in a minute, but essentially it's Google's version of a Jupyter Notebook. And as I mentioned, it is free. So you can use a GPU on it. You get basically the same GPU that you're already training on GCP, the P100. It's pretty nice, and it's Google, so like it's pretty affordable. There is a paid version of Colab that gets you some more time to use, and it's like $10 a month. So if you are finding you're using Colab all the time, and if you want to start trying some training on Colab, I definitely recommend checking out Colab Pro. So as I mentioned, it's free. That's the biggest benefit of it for sure. What I like about Colab is it's text and code. So we'll look at the sample file that Leah and I put together this week. And basically you could just read a lot of the description of what we're doing, and then you could execute certain cells and actually run the code. So it's sort of nice as tutorials to help sort of like understand what you're reading and then also be able to run certain code as well. What's also cool about it is there are web URLs, so you can share them. The sharing features of Colab are a little tricky. Like you can't just like Google a Colab file. But if I've started to collect a bunch of like Colab files if you're interested in playing with things. Downsides of Colab are that there are time limits. So with a non-pro Colab account, you get about 10 hours of time to run before it shuts off your machine. And when it shuts off your machine, you're going to lose all of your work. So a lot of what we'll work on is like how to download stuff quickly. There is a way to connect your account to Google Drive. So you can also drag your files from Colab into Google Drive. Now, once your machine has been shut off, you can immediately restart it and pick back up. So it's not like you get 10 hours a day. It's like you have just a 10-hour session. And there are also things like if you walk away from your Colab file and don't use it and it's not running a process, say for like 30 minutes or an hour, it'll also auto shut off for you. So you have to be kind of careful about what you're doing. It makes Colab a little bit annoying for things like training and other things. And I think that's on purpose. It's mostly used to like do just-in-time sort of inference and stuff. There are some GPU and CPU limits, but for most of us, we won't really run into them. But it's like you only get one GPU. So it's not like you can be like doing crazy training on these things. And lastly, I should mention is Google. You know, everyone has their own ideas about tech behemoths, but you know, I have personally found that Google's fine. I doubt they're looking at my files or anything, but that is always a thing to be concerned about if you are. And obviously, like as I mentioned, like the biggest thing about Colab is that it's free. That's why a lot of people use it. And it's fairly easy to set up compared to like a Jupyter Notebook, which has to run on a server. So as I mentioned, I won't really go through this list, but if you are interested, I have a bunch of ML Art Colab notebooks. So after you've like sort of gotten like used to Colab, there's a bunch of files here you could play with that are publicly accessible notebooks. Okay, so really quickly, I'm going to jump over to Colab and just sort of like walk us through the basics of how a Colab notebook works. So you go to it by going to colab.research.google.com. The first thing you'll experience is a screen like this. I have a bunch of already created notebooks here, but I recommend like either opening out someone else's notebook and sort of learning by how they're working, or just creating a new notebook from scratch. I'm going to go ahead and just like for this demo, just create a new notebook from scratch. So once you've created a notebook, you sort of end up at a blank page, and you might not know what to do here. So there's a couple of things you can do here. First is that these gray boxes are cells, and they basically run just like code does. So we could actually put in here. Actually, before I do that, let me jump to how to actually like start one of these machines. So when you open your Colab notebook for the first time, you won't be connected to like any GPU or CPU or anything. See, there's a button over here that says connect. You could click that. There's one thing I want us to set before we actually do that. So you come over here to runtime, click on runtime, and you go to change runtime type. And you will come to a page that says hardware accelerator, and then run. You might not have, I think because I have Colab Pro, I see the runtime shape. So the first thing you want to do before you start anything is make sure your hardware accelerator is set to GPU. If you don't set this and you start working on like StyleGAN stuff, you'll have to restart your machine, which means you'll lose all your work. So make sure the very first thing you do is actually set this to be a GPU. If you are using Colab Pro, I definitely recommend just using high RAM, just because you should. That's like one of the things you're paying for. Most of you won't see this one. Hit save, and then you're ready to actually hit connect. So when you hit connect, this is actually going to connect you to a Google server, just like GCP does. You are now running a server here. So one thing you can do to tell is, because I'm running a GPU server, I can run a command called NVIDIA-SMI, and this is going to tell me some information about my GPU and what exactly, what machine I'm running. So if I hit, basically there's two ways to run a cell. You can hit this play button, which will play this cell, but most people just do shift return. So if you click into the cell and you hit shift return, oh, interesting. Oh, I know why. Another thing to know about Colab is that this is the command you could run on your computer or like whatever, or like on a server. This is what you would run. But in Colab, what you actually need to run is you need to add an exclamation mark ahead of it. In most cases, you'll just add an exclamation mark in front of any command that you want to run, and that just tells the interpreter that you're running like a CLI command essentially. Okay, so that worked. So you'll see here that we are running a Tesla P100. So this is an easy way to just sort of see like what machine you get. If you don't have Colab Pro, they might give you like a K80 or something else. Those are still fine to do inference off of. You might run into errors if you try to train using this. Colab Pro will pretty much always give you like the best GPU they have available at the moment. You sometimes get a V100, but it's pretty rare. So often you'll just get a P100. And that's plenty for what we're working with. But I just usually run this command just to make sure that I have a GPU and that we're running with stuff. So what's nice about Colab is that you also have the option, if you hover over sort of the center of your area here, you have the option of adding a new code cell or adding a text cell. So text cells are really cool because they basically just use Markdown. So so we can just add text here and then say this is a description of what I'm doing next. So this is pretty popular in like the data science community because this is basically a way for them to like describe what they're doing or like where the data is coming from before they start processing it. And then I could share this with someone and they could run the exact same process and see how it works. So this is basically what Colab is set up for. It's set up to do like data science notebooks. But because machine learning and data science are so closely related, there's a lot of work that overlaps. Two things to note over here are on the left-hand rail here is when you have a crazy long notebook, this will show you like sort of a section view or a table of contents view. So if I add another text cell here, you'll see that now we get subsections. So sometimes if you're not sure like where you're going or like where to find a thing in a notebook, because like especially the notebook that Leah and I are going to share, it's like very, very long. So you might want to come to the table of contents view and jump around just to find where you need to go, or just to jump around. It's a little bit easier to go from here. This section is a part of code snippets. I personally generally don't use these code snippets, but it's helpful if you have like, if you are looking for certain things to do, like there's a way to do, oh, I could have maybe used this yesterday, which is like showing images using CV2, other things. There's a lot of code here if you are interested in doing stuff like more data science-y things. And then the last one, the one that I mostly stay in, which is the files folder. So this is actually where, as you build up files, so let's just say git clone, let me just grab my StyleGAN repo here. So this works, again, just like it would on a server. So I'm going to say git clone. And as I run this, so shift return, it's actually going to clone this down into my file section. So if I hit refresh here, you'll see now my StyleGAN2 folder here is here. So basically, this is a file viewer, just like any server. This is really helpful just to sort of see where your files are. And then you can also, if you right click on a file, you can download it, delete it, rename it, do a bunch of like sort of like file management stuff. The last thing I will note here is that there is a button to mount a Google Drive account. We won't do this in our demo today, but I do recommend that you actually use this for your work, just because it's a little bit easier to save stuff directly to Drive than it is to download everything by hand. So if you come over here and click this Mount Drive button, you're going to want to say, yes, I want to connect this to my Google Drive account. You'll be asked to sign in and connect your accounts. I'm actually just going to pick this one. And then what you'll see here is now you have a cell here that you need to run. So if you hit shift return here, it's going to lead you through a process to basically connect your account. Like you have to go in, you have to like create approve that it access to certain things, and then you'll get a access code, and you'll copy that access code and you'll paste it here, and then you'll hit return. And then actually, let's just do it so I can show you what happens. So I want this account. I want to say yes to these things. And then you'll hit copy here, close this window, paste that code in here, hit return, ignore 1Password. And if it works right, yep. So now if I refresh my Finder over here, all of your Google Drive files are now here. So you have access to them. You can literally like take a file from here that you want and use it in Colab. Like say you want to read in a file or something, you can read it in from here. You can also write to it using the paths. Now, one thing that's a little annoying is that there is some latency issues between Colab and Google Drive. So I don't recommend actually reading like your TF records files from Drive into Colab. I recommend actually moving them over because those are huge files, and just the read time between Google Drive and Colab is kind of messy, and you will get errors if you try to like do that. But this is pretty cool. This is why I recommend like everyone have a bigger Google Drive account, because you can save stuff directly to Drive, and that like is sort of a game changer because you don't necessarily know if your machine is going to get cut off at any point. Like I generally like recommend just like, I'm going to check and like, okay, it's 1:15. So maybe at 9:15 tonight, my machine will get shut off if I like am continuously running stuff. If I stop my machine and I don't use it for 30 minutes, it can just get automatically shut off on me. So it's kind of like a little bit of a chase with time, but it's pretty fine in general. So yeah, so that's Colab. You'll probably be learning a lot more as we go through various files and things, but this is sort of a general introduction and should be worth noting. And like you can save your files directly to Google Drive. You can also, if you have a GitHub account, sorry, Bug's hair is in the way. You can also save these to Git. You can save them to a Git gist, like any number of things. It's a pretty cool way to work. And basically, I like to do this because if I already have a pickle file saved onto my computer, Bug, seriously. If I have a pickle file saved on my computer, I can just open these in Colab really easily and build some and generate some images in like 10 minutes without having to spin up a GCP server, without having to pay money, like all that sort of stuff. So Colab's nice for quick, fast things you want to do. It's a really, really nice way to work with that. So that is Colab. So we are a little over time. I'm going to run, let me see. Okay, so why don't we take a break? We'll come back at 25. I think class will run long today, but again, we're recording everything. So if you need to duck out, please feel free. But we have a lot of stuff we're gonna play with inside of Colab. So let's come back at 25 after, and we will keep moving on stuff. Thanks, everybody. You are a little jerk. You're a little jerk. So it turns out my partner is also doing a Zoom. So we're really gonna push the limits of the New York Wi-Fi here. So Esteban, looks like you have another question. Do you just want to go ahead and ask it? Maybe he's not back yet. Okay, just for, well, I should probably wait till he gets back, just so he hears the answer. All right, maybe we'll find a time for a break a little bit later and I can answer. Oh, there he is. All right, so Esteban, your question is, how do I delete a folder in Colab that contains files? Tried using the delete option, it didn't work. So that is correct. That is because you cannot delete a folder that has files in it. That's like a server thing. So the way to do it is actually to use something, a command cell, which is, I'll write this out, but essentially it's what you want to do is you want to pass the path to the file. So you're going to do rm-rf, and then the path to folder. So what that will do is that will iteratively go through the folder and delete all the files and then delete the folder itself. Yeah, that's something that I assume that like Colab will fix that soon. But that's actually just like a general, like just sort of server thing, is you can't really delete folders that have files in it unless you use this command. Any other questions? So go ahead.
Sorry, I didn't see what you did. I don't see your screen.
Oh, I put it. Oh, yeah, that's because I sent it to Leah and not to everyone else. So hold on a second. So it's in the chat. So basically, you use this command, and that will delete any folders and files. Cool. Okay. Any other questions before we jump back into slides? All right, sounds like we're ready to go. I need a screen share again. Cool, and everyone can see my screen, yeah? Cool, all right. Okay, so latent spaces. Leah, are you gonna cover this or am I gonna cover this? I forget.
Can you cover the latent spaces and then I'll jump in for inference?
Cool, perfect, sounds good. Okay, so latent spaces. So you probably maybe are wondering, like, what did I just make when I trained my model, right? Like I have this model, but I don't really know what it does, or I don't really know how it thinks. So we're gonna talk a lot today about latent spaces. And you'll hear this talked a lot about, especially around GANs, because the cool thing about GANs is they produce what is called a latent space. Okay, so let's think about this. Let's imagine that in this two-dimensional plane, at every one of these dots is an image. So like, let's say at this dot, there is an image of this person. At this dot, there is an image of this person, right? So the model essentially is like envisions all of the data you fed it, and it turns those into faked images. And those fake images exist in what is called a latent space. Now, in reality, at every single continuous point within this space, there is an image. But just for the sake of like demoing this, I'm going to show you that like there are some discrete points that have images in them. But remember that like any point within this space has an image. So, and the next thing to learn is that like, okay, so at this point, we've got this person. At this point, we've got this person. If I pick a point that is closer to this dot, I get a image of a person that is more likely or closer to this person, right? So remember that basically in this space, points that are close to each other produce similar images. That's the next thing to know. So in this latent space, things that are far away produce different types of images, and things that are close by produce very similar results. So this is us viewing this thing in 2 dimensions, right? But the truth is that StyleGAN works in 512 dimensions. And so like, we can't really wrap our heads around that, right? Like we think in 3D, maybe 4D if we add on time, but like there's no way to visually represent 512 dimensions. But essentially that's what they're working in. So sometimes people ask me like, what are those dimensions? And that's a bit of a tricky question because it's not like one of those dimensions is like hair length or one of those dimensions is eye color. It sort of ends up being a little bit of an amalgamation of that. And we'll talk a little bit about how StyleGAN works to what we call disentangle those features in a minute. But essentially like inside of these spaces, every one of these points is represented by 512 dimensions. And what that looks like is if you know code, that is a 512 dimensional array that is between -1 and 1. And that's a float number. So it can be like, you know, 0.000032. And they're like, all those are represented by 512 different points. So what we're gonna do today is actually start to pull those images out of those points and actually like look at how we can manipulate these points, which because they're now mathematical values, right? There's a point in space. We can begin to do things like shift it a little bit or add 2 points together. So we're gonna look at all those things and how they help us generate images in different ways. That's you, right? Cool.
So the first of many manipulations we're going to cover in this class is inference. How is this distributed spatially? So Moises, your question about how is latent space distributed spatially is kind of hard to visualize because it is the 512 dimensional space. Oh, TSNE or PCA. So those 2 things you listed are techniques for people to kind of view 512 dimensional space in an easy human readable format. So TSNE is like an algorithm that given like a 512 dimensional space will kind of like project it down to 2 dimensions so you can view it. And a nice property of the algorithm is like if things are far apart in 512 dimensional space, it projects it down so that they're far apart in your 2D image of it. Yeah, I hope that answers the question. Okay, so going on to inference. Inference will be basically once you have your model that's trained or you're using a pre-trained model, how to generate new images from it. So what this means in terms of the latent space is you're essentially just grabbing random points in it and then just producing the corresponding image. Inference is also referred to as evaluation, also referred to as testing, but they all are just terms between generating new images from your trained model. So here, we're going to go through some Colab demos throughout the rest of the class. This notebook here will have all of them linked together. Let me bring you to that notebook over here.
And I should add, and just one thing to note is like, I don't recommend actually following along with this notebook because we're going to be going through it pretty quickly. But like, since we have the video, you can watch the video afterward and like sort of follow along again. But we will make sure you have links and everything to this. So yeah.
Mm-hmm. Cool. So if you open up the notebook that we linked, it's going to have, as Derek said, in this table of contents. Here I'm going to cover inference, and then we're also going to cover truncation, interpolation, mixing seeds, and projection later in class. The very first part of it is just kind of getting all the pieces together, downloading your StyleGAN2 repo, and then also downloading your trained model that you want to work with. You can use GDown if you have it saved in Google Drive. Yeah, so moving on to inference. This is the command to run inference. A couple things that are important about this command is it takes 3 main parameters. The first one being the path to your trained pickle file. So here, this path, I can just come in here and grab copy path and type this in. There's also the second argument, seeds. What seeds is here we're passing in seeds 1 through 50. And what this will do is it will produce, the result of this command will produce 50 new images. And why this is called seeds is because it's like short for random seeds. And each different random seed, like random seed 1 or random seed 3, will generate a different random vector of 512 numbers, and each one of those random vectors corresponds to a random point in the latent space. But you'll just generally use this number to tell it how many new images you want it to produce. And the third argument is truncation. We're going to cover truncation more in depth in a little bit, but essentially truncation is a number that you can pass in which ranges from 0 to 1, which specifies how realistic or not realistic you want the generated images to be. 1 will be very weird and not realistic, and 0 will be the most realistic. In general, I usually do 0.5 or 0.7. So running this command, you click run, it will go through and generate each of them one by one. This might take, I don't know, about 2 or so minutes for this to run. But after it is completed running, they will be saved in a results folder under your StyleGAN2 folder, and they should all be in here as seeds. And they'll be named by the number of the random seed. Yeah. As you can see, it's running pretty fast one by one. Ted asked, is mode class basically getting stuck on a local max or min of latent space surface? Yes, essentially, yeah. It's when your generator and discriminator are just kind of stuck in a local feedback loop. Yeah, and I would think of it in that way. Moises asked, is truncation running at 1 like overfitting? I wouldn't equate the two. Truncation at 1 will just produce really weird images. I think we can go into more detail about this in the next truncation section. And Octavian asks, can you generate a result by inputting an array of numbers to the model? Derek, do you know the answer to that?
So the answer to that is not from this notebook. But if you like sort of clone your own version of the StyleGAN repo, you can sort of directly access that sort of Z space and be able to generate latent numbers and just like input them in. If you're interested in that, let me know. I have a notebook that can show you how to do all that stuff. Yeah.
Okay. So all of these seeds have been generated. It only took 48 seconds actually to generate these 50. But this command will just let you grab a couple. So here you can say like, I want to look at seed 5 and put that file name in, and it'll show a couple. These are just from a model I trained a couple months ago from a Flickr data set. And there's, like we said in Colab, there's no great way to like view a bunch of images at once. So what you'll need to do is you will need to zip this entire folder and download it locally. And then you can pick seeds that you like and decide which ones you want to use in other things like a latent lock. And yeah, saving up the seed number and also knowing your truncation value will allow you to be able to reproduce that exact same image from your model.
Yeah, so I know Esteban has asked a lot about seeds, and the thing to know about a seed is that it's like, so no, like say seed number one just produces, it always produces the exact same 512 dimensions of a number. So basically seed one will always give you the same image if you're using the same model. Now you also have to have the right truncation value, but like those, if those two match, you'll always get the same image. But you can produce millions upon millions of seeds, and you will always get a slightly different image. Now, like realistically, if you produce 1 million images using this model, you'll find images that look very, very similar to each other, because like the randomizer might be like 0.000001 of a float difference from another image, in which case like our eyes will just be like, that's the same image. So there is like probably some bound of which like producing so many images will produce the same image. But it's pretty like inconceivable like that you would actually produce that many images. So you could produce 2,000, 3,000, 4,000 images, and all of them will be slightly different. But what's nice is those seeds give you that like access to go back to one. So if you say, I really like number 50 and I want to go back to it, you can use seed 50 to always find that same image. Yeah, so like there are lots of questions around seeds and like, can I produce millions upon millions of images? And the answer is yes, you can. Don't recommend doing it in Colab because downloading that zip file will never happen. So I generally say like produce images in batches of like 200 or 250 at most, because that's going to be about 200 megabytes of an image. And zipping those and downloading those can take time because Colab is pretty slow. You may find that if you can drag stuff into Google Drive, like by mounting your Drive account, it will sync up pretty seamlessly or pretty quickly. But then you still have to download them from Google Drive to access them. So it's a little bit of a mixed bag there to try to like get those files down to view them. Again, what's nice is like Colab gives you access to these tools for free, but getting them is a little bit harder into your local machine. Moises, I don't know if I understand your question. What is the translucent value?
Maybe I misheard, but I heard there was a translucent value or
truncation.
Okay, truncation.
And we'll talk about truncation next. Yeah. Cool. All right. So I'm sure people are gonna have more questions, and hopefully we'll cover them as we get further along. Okay. So it is my turn to share again. So we've covered a little bit of inference. So now we're going to talk about truncation. So truncation is this concept. We'll play this video here. I think I might have shared this before, but basically truncation is a way. This is the exact same seed looking at a truncation value from 0 to about 2. So you'll see here that at 0, truncation of 0 is always this woman, in FFHQ at least. This is what's called the most average woman in StyleGAN. Not to be mean to this woman, but like basically she is the 0, 0, 0, 0, 0 for 512 dimensions. She is the 0 point for the FFHQ pickle model. Now, as you scrub further along, let's say this is about 1. So see like this child still looks fairly like representative of a human, but some stuff going around her body are like pretty weird, right? So this is probably the truncation value of 0.1. Now, if we get really far out, this is probably a truncation value of 2, if it didn't even let me go that far, because it finds that image hideous too. This is getting really far out, right? So the further you get out, the weirder these results get. And I think technically truncation is infinite, but like at some point, like probably like 3 or 4, like you're just gonna get pure noise and it'll be really weird. At least I would assume. I've never really tried to go past like 3. So let's talk about what truncation actually does. So let's imagine again our latent space. Now, an important thing to notice is that if you're at the very middle of the latent space, right? Remember, it goes -1 to 1, -1, or sorry, yes, -1 to 1. So it's 0, 0, 0, 0, 0 is that average woman. So the idea here is that everything sort of centrally located are like the good images or like the most representative of the model. The further out you go, the weirder it gets, right? And that's sort of what happens with truncation. So what truncation does, it says, hey, rather than giving all the edges of the space equal value, truncate my space. So now when I work within this space, it's more likely that I hit a more average or more possible image from my data set. This is all truncation is. It's a crazy, like there's crazy math behind it if you're interested in seeing the paper for it. But essentially this is just a way to get more access to different images using those same values. This is truncation. I will show you in Colab how to actually do, so I have a model here that can do a truncation animation. So if we look at, where am I here? So I've already run this. I sort of already run a couple of the commands that Leah was already running. So here's my generate images. I'm gonna close this. Oh, the other thing I should note is that if you wanna close all the output, you just hover over this little button here and hit X, and that will close all the output. Nice to keep your file clean because it can be like a really long scroll here. So I'll actually close this zip. So truncation. So there is another command here that you can run that is called, it's still using run generator, but it's called truncation traversal. And what this does is it takes your network image, it takes a seed value. So again, this is the same seeds that you were generating using the previous values. So say I really like image 20 and I just want to see what image 20 looks like when I do a truncation traversal, or like animate across the truncation values. You need to give it a starting value. So I'm going to give it a starting value of -2. Truncation can go negative. So it goes from negative whatever to positive whatever. So most people will usually go from 0 to 1, but you can also go from -1 to 1 and get different values. And then we're going to have a stopping value. So I'm going to stop it at 2. And then you have an increment value of like how many do I want to increment it by, right? So it's going to start at -2.0. The next frame that it generates is going to be -1.9 all the way up until we hit 2. So I'm going to run this command. And again, these usually don't take too long to actually run. But it will take a minute or two. So after this generates, what we'll do here is we will use this line of code to generate, to just like show us a couple images directly in Colab. So we're gonna look at like -2, -1, 0, 1, and 2, just to sort of get a brief overview of how this works. So see, it's starting to generate the values now. So it's generating a -2, -1.9. Now this usually is a little bit faster. I guess I find that it tends to speed up as it goes through the process. So it'll get a little bit quicker as it goes. See, there's a question in the chat. Okay, so Moises, I'll send you the paper to it. Truncation is actually used in Big GAN as well. I know you're a Big GAN fan, so truncation is used in Big GAN as well. So as you'll see, this is now generating results. Now it's important to know that all of these get saved in the results folder. So just like your training models, you'll see inside the results folder, they'll be numbered. Now, the important thing to know is that in Colab, you want to make sure that your paths to the right files are generated. So when you go down here to the zip, I guess we don't have a zip file here. But when you go down to make a video out of this, you want to make sure that your numbers here match up, and that inside of here, this is called frames. You want to make sure that you're using frame here. I realize in some of my code, sometimes it says frame and sometimes it says step, so make sure the files match up. So I'm going to go ahead and get this set up just to make sure that I can run this really quickly. So this is a command. This is using FFmpeg. I think I've talked about FFmpeg in here before, but basically this will generate, when we're finished here, this will generate a video using all of these, using all of these frames. So it's going to turn this into a little animation, and then we'll download it and look at it. Just about finished here. All right, so that process took about 2.5 minutes. So it's a little bit longer. I'm just going to start running my FFmpeg command. So this should happen pretty quickly because it's just it's like 40 frames or so. Looks like it's finished. All right, so before I download that, let's take a look at what a couple of these frames look like. Oh, and that's because I named these wrong. It's going to be 0, 0, 0, 0. There we go. Okay, and while that happens, let me download my video here. Okay, so these images have been generated. So again, remember, this is -2. This is 1. I think it's still generating some images here. This is like, generating images in this thing is pretty slow. So let's just actually look at the video. So let's come up here. Okay, so this is an animation of the truncation traversal. So this is -2. This is probably about 1 right here. This is 0, so you'll see 0 looks very similar. So like between 0 and like 0.5 or 0.7 or 1, like you get some pretty good images. And then again, so now we're going to the positive. So here is probably about 1 here, and then here is 2. So you'll see like looks nothing like her training set. This looks somewhat like her training set, but still not perfect. And then as you get closer, you get more along the lines of what her training set looks like. So this is essentially truncation. And you can do this off any image, right? So like I could come back here and I could change my seed value. If I go back up here and I change my seed value to say 50, I can also see what the truncation looks like at that range. This is just a nice way to maybe test to see, like one thing I would do is if I wanted to produce way more frames, I would change this to 0, 1, and that's gonna produce like 10x more frames, right? So if I wanna understand sort of my truncation space, or maybe just understand like, I like this image, but does it look better at a certain truncation value? I might set this and just sort of look at those frames. But this is just a nice handy little thing to check out. It also produces really weird images using it. It always shocks people that there's these like disgustingly weird, grotesque images in places inside your model. So if you want to like, you know, do a horror show, this is a good animation to run. All right, that is truncation. Any questions? Oh, okay, so Kyle asked, I'm having difficulty understanding how walking the truncation value changes the image result as a seed is held constant. Yeah, so this is sort of like just some like kind of mathematics where it's actually sort of like, it's actually wrapping the value around the space. And I think the idea to think about is actually that like, maybe if you imagine this as like, you're actually compressing the space, that then maybe your point is shifting a little bit as you compress the space. Let me know if that makes sense. But yeah, it's sort of like, yeah, it is like a hard concept to sort of follow. And like truncation doesn't really work like this, but that's how I sort of imagine it working. And that sort of helps me understand what's happening there. So Octavian asked, is the number of maximum files a model can realistically generate? I don't know. I mean, again, it's sort of like, saying it can generate, you know, any number. It sort of depends on your floating value. If it's like a 32-bit floating value, you have like a max or a cap there. But yeah, some of it matters on the training data. So it's like if you train it on a lot of images and it learns the representations really, really well, there can be tons of data in there. If you only feed it 1,000 images, there might be overfitting within certain regions. So you might just see stuff that looks pretty similar in certain regions. I've sort of noticed that that's common. That's not really overfitting because you can still animate between the spaces or it still understands different representations. But just sort of like there's localized clusters that look very, very similar to each other. But yeah, so it's like there's lots of different ways to think about that. But I would say the maximum number is probably like very, very large. But again, it just comes down to like, if you put an image of a human and an image of a human that look pretty similar, can we actually tell the difference between it? Okay. Okay, so now we're going to talk about StyleGAN actually has 2 latent spaces. So this is where it's going to like our mind is going to slowly explode in this whole session. Okay, so technically StyleGAN has 2 latent spaces. One is called Z and one is called W. Z is actually the train space. So most GAN models have a Z space, or actually all GAN models have a Z space. And this is what we call the train space. This is sort of like regularized to make sure that every area inside the latent space has images available to it. What happens in this space is that we get a thing called entanglement, which I'll talk about in a minute. But basically, like, this will determine that all of the features that it has found can be represented in all of the spaces. So basically, like, at some point in space, at -1, all the way through 512 dimensions, there is an image that can be represented there. That is the point of a Z space, is to make sure that the space is filled, essentially. Now, StyleGAN has this thing called the W space. And what this is this is a space that StyleGAN represents to try to do what's called disentangling features. And the way I would describe this is like, you don't want a thing that doesn't exist in your data set to exist. So for example, like if I didn't train this on women with blue eyes with red dreadlocks, like they shouldn't exist in this space. So the W tries to actually map more realistic spaces. And it also tries to make sure that your interpolations through that space are better representative of the features that you're trying to interpolate. I'll get to that in a minute as well. Because that is like, this is a pretty heady concept. And like, I would say even a lot of people who work in StyleGAN don't think about these two spaces, but these two spaces exist. In general, if you can, you want to pull images from the W space, because the W space is better representative of the actual model and less representative of like just the way that training data is smushed together. Okay, so again, this is what was I trying to say here? Okay, so let's imagine that you want to interpolate from, and we'll talk about interpolation in a minute. Let's say you want to move from this dot to this dot, and let's say you want to do it in 5 steps. So you'll do 1 dot here, you'll do 1 dot here, you'll do 1 dot here, here, and here. Now, if I'm moving from this face to this face, I would expect there to be a change in smile to sort of a non-smile. I would expect there to be some sort of generation that like moves their hair, as well as adding facial hair, right? So let's look at, this isn't the same images, but let's look at some examples of like what happens in these different spaces. So this comes from a artist by the name of Justin Pinky. There's a link to his Twitter thread if you're interested in this more. But let's say we're animating from, or we're interpolating from this image to this image. Now, there's 2 things wrong I see in this image immediately, in this interpolation. And I'm interested to see if people can guess what the interpolation is doing wrong. So if you look at these 3 steps between here, can you see anything that doesn't make sense to you?
Glasses in 4th frame?
Yep, that's one. So the glasses in the 4th frame, right? This person doesn't have glasses. This person doesn't have glasses. How are glasses showing up in this interpolation? There's one more.
The earring?
No, the earrings are okay. Although like, that actually is interesting that there is no ear in either of these, and yeah, that's actually a 3rd one. That's a good one. Octavian has it, so the teeth. So this person is sort of smiling in this middle one, right? This person has a flat facial feature, and this person also has a flat, you know, it's not frowning, but it's not smiling. This person ends up with teeth in the middle. So this is a case of where here again, you're seeing interpolation in Z. This is what we call entanglement. Basically, entangled features are things where if you are do a linear interpolation between these 2 images, eyeglasses shouldn't show up, their teeth shouldn't show up. But because of the way that data is smushed inside the Z space to make everything fit, you do get what is called entanglement. And that's where these eyes and these teeth show up. So let's look at the next example. So the next example is a what's called a spherical linear interpolation in Z. Now, most machine learning GAN artists will tell you that spherical interpolation is better than linear interpolation. And there's a whole reason for that. If you are interested, like there's like this crazy concept of high dimensional spaces, but essentially they believe spherical linear interpolation is better. So let's look at this. So this is better, right? In the sense that her teeth aren't showing as much. And I would say like this representation between these 2 steps makes sense, right? Like the face is turned a little bit more. I'm seeing the right sort of ears dimension, that sort of thing. But I'm still getting the glasses. So this is still, even though this is better, I'm still seeing some entanglement. Okay, so now the last one is a linear interpolation in W space. And look at this. So this is almost like exactly what I would expect to see, right? No more glasses and no smiles, no teeth. So in a lot of cases, GAN people will tell you, like, especially with StyleGAN, to do a linear interpolation in W. And I would say if you want a clean interpolation, that is the right thing to do. But we're artists, like I'm okay with a little bit of noise. This seems fine to me. So there's different options here, but just be aware of these different spaces and know that if you can do it in W and you want that really smooth, clean interpolation, to do it in the W space is the right way to go. So a disentangled space is where you interpolate between a woman with a hat and a man with a hat, and you shouldn't lose the hat and gain glasses. Like these are really, really helpful. Like this is the most helpful images that I've seen to sort of understand entanglement. So let's look at how to actually do this inside of a latent space. So again, I actually want to move from this to this, but I want to do it continuously. So rather than have those 5 steps, I actually want to just take as many frames as I can between these spaces. And I'm sure, as you can imagine, like what you're going to end up with is an animation. Now, this was probably done in Z space, but it's still like pretty decent. So you'll see here, like, you know, this person's hat is growing from like a capped hat to like a fishnet hat, I guess. It's like, I don't know what exactly is going on there with his head. But basically it is interpolating from this point to this point. And this is how we make animations in these things, right? We take sort of like as continuous as we can of all these points along this line. And then we can stitch them together, and our human eye says that's an animation. That's a continuous video, not like a bunch of static frames. So inside of the Colab file that we have available to us, there are 2 types of interpolations. There is a linear interpolation and there's a random noise loop. Now, you may find that other people have other interpolation models. So there is that spherical model. So if you want to do something that was like sort of entangled, sort of disentangled, you could do a spherical model. I actually had that working for a minute and then I broke it. So if people are really interested in that, I'm going to try to bring it back over the next week or 2. I would say linear is actually better. Like linear, especially in linear and W, actually works better than spherical in W, the StyleGAN creators found. So that's why I just have a linear model. It's pretty easy to understand, and you sort of know what you're getting. There's also a version that's called B-spline, which tries to smooth stuff a little bit. We'll talk a little bit about smoothing in a minute. I also tried to get this one work, and I got it working in like a outside of like basically just with the raw Colab code, but I couldn't get it working directly in the model. Might come back to that. And then we're gonna look at random noise loops. These are just fun ways to just build like a very quick iteration of your model. So linear interpolation. So linear interpolation just literally moves from, we're gonna feed it a number of seed values, and we're literally gonna move in a line from one seed value to another, to another, to another. And that's like what we sort of saw in the previous example. You basically have control of what we would call these tween points. So like these endpoints that you're gonna move to and from, you have control of those. And one thing to note is that if your first seed equals your last seed, then it's gonna loop, right? So if I start here and I go up and I go down and I go up and I end back where I started, that is essentially gonna be a loop. And that's really good for stuff like Instagram or GIFs or whatever. One thing to note about this is that the speed can feel a little uneven due to distance between points. And I'll touch on this in just a minute. What's nice about this is you can use this in Z space or in W space. So this is where if you want that really smooth, clean interpolation, you can do linear interpolation in W space. Okay, so here's a visualization of how this works, right? So I pick these points, and these points are images, and they're assigned to a seed value. And you basically say, I'm gonna move from this seed to this seed to this seed to this seed to this seed, and then back, right? So this is gonna create a loop. Now, one thing to note is that if basically the way this model, or the way the code works is that it generates the same number of frames between each of these interpolations, or between each sort of linear move between each of these points. So if I have 30 frames between this and this, I'm gonna get a certain speed. If I have 30 frames between this and this, it's gonna be a little slower. And if I do 30 frames between these two, or sorry, actually it's gonna be the reverse. This is gonna feel faster than this because how many frames it actually feels like you're moving over that space. Whereas if I go 30 frames between these 2 points, it's gonna feel really slow because I'm moving a very small amount between each of those frames. So this isn't a perfect way to feel like you're getting very smooth motion. And in fact, it's like kind of hard to figure out the distance between all these seeds. We could probably do it if we really wanted to, but it's gonna be a little tricky. So I would just say like one thing to note is that you might actually want to break these up. If you want to do stuff in like After Effects and make a very smooth animation, you might actually break these up into different tasks and then bring it into like After Effects or something and actually control the speed of those moments so it does feel smoother. But this gives you control over these points, which is nice to be able to say like, I want to go from this person's face to this person's face. Okay, so I'm actually just going to show us how to do that inside of Colab. So inside of Colab down here, we'll come over here to our table of contents. We're gonna go to interpolation. And there is a command here called run generator, and it's called generate latent walk. So you will use this command. Again, you're gonna pass it a network. You're gonna pass it a walk type, which we'll talk about in a minute. And then you're gonna pass it definitely a number of frames because it's like how many frames you wanna get, and then the truncation PSI. So the truncation is again like a thing that matters for all these images. And then you want to make sure that's set to the value you want, right? Because if you change that value, as we saw with that truncation, you're going to get different images. So how does this work? So we have here this command. and you'll see that we pass in a network, pass in the line type. So we're going to do a line in Z. So it's line dash Z will give you a Z space linear interpolation. The next thing you're going to do is pass it seeds. So these are the same seeds that you could find using the generate images command that Leah was showing us. So what I usually do is I generate 500 seeds. I'll download them and I'll look at them and I'll sort of say, oh, I want to animate from this seed to this seed, from this seed to this seed. So then I input these seeds as inside of like with comma separated. So you'll notice here that I'm starting at 58 and I'm ending at 58. So when you start and end, you get a loop. If I were to take this out, this would not give me a loop. This would give me a continuous line and it would stop at this 47. So I'm gonna put this back in. And then overall, I wanna do this in 100 frames. I'm only gonna do 100 frames for this because I wanted to generate stuff really quickly. I would generally recommend for this many seeds, you do a higher number of frame rates, but let's just run this and see what happens. So come and click in the cell and hit Shift Return. And this is going to generate my images. And you'll see that was faster. So basically, this little like setup TensorFlow plugins, the very first time you do it in your server or on Colab, it's a little slow, but then it gets cached, so it runs a lot quicker this time. So this will run pretty quickly. So one thing to note is that this particular model, because you have to do this like interpolation, I might not be able to split 100 frames evenly across all these. So it does some math. So sometimes you end up with a little bit more frames than you expect to make even changes between all the images. Let's see, we're about halfway there. This is happening pretty fast. And if I come over here and I look at and I refresh my folder, you'll see I get a new results. So this is generate latent walk. If I look inside here, you'll see I have a bunch of steps. So what we're going to do next, once this is completely finished, is we're just going to turn this into a video really quickly. For me personally, I almost never download these latent walk images unless I want to pull one out and just like play with it in like Photoshop or something. I pretty much just always generate to a video and then just like download the video and just work off that. That's maybe if I want like the highest res, no compression video, then I would do it in a different way. But for me, it's mostly just to try sketches and try things out. Okay, so it's finished. It took 1 minute and 20 seconds, which is pretty great. So let's go into this cell and let's hit Shift Return. And this is gonna throw an error because I did not name my folder correctly. One thing to note is that Colab usually saves your previous session or like whatever. So you have to make sure that you go in and edit your each of these commands to match sort of the newest thing. So now I'm at 0001. Let's run this again. Another thing to note is that for this FFmpeg command, you pass it your input of your files, and then you also give it a name. So I would generally it's always good to name your files. If you name this video and then you have 30 videos on your desktop, you're never going to know what's what. So try to name them in a way that makes some sense. So I'm going to come back down here. If you don't see your file here, sometimes you just have to hit refresh and that'll refresh your view, but this did show up here. So I'm gonna download this. It should be pretty fast. It's 6 megabytes. And actually, while this downloads, there is also a way to do this in W space. So let's actually run that really quickly while this downloads. So to change this exact command and just put it in W space, you actually just do line-W. So the W is just going to assume that you want to do it in W space. So you just pass it line-W. I'm going to use the exact same seeds because I want to show you a little bit of a comparison between the two places. So let's run this one. Well, this downloads. So this file is now ready. So show in Finder. So now we have a very, very quick line interpolation. So you'll see it stops here and it starts here. So this is going to be a loop. So I could set this to loop within QuickTime. Actually, let's do that. Oh, this isn't in QuickTime yet. Just double click, view, loop. And if I just hit this, it is going to loop. So this feels very, very fast because I have a small number of frames and a lot of seeds. So the way you control this is like, you kind of want to think about how many seeds am I producing and how many frames am I producing. Just play with these and you'll sort of get a feel for what works and what doesn't. But in general, this is like pretty chaotic, but you see that it does move rather smoothly through a lot of these spaces. So this is pretty interesting and pretty cool that you can just do this in one line. Okay, so we are generating our W space. Yeah, so Anastasia asks, like, how do you generate high-res individual images? So there's no real high-res. 1024 by 1024 is as high as we can get. There are other models that can do some up-resing that are like machine learning models that I can share with people. But basically, you generate images in the same way that Leah was showing, which is just like generate lots of random images, and that will produce your image for you. That is a 1024 by 1024. Moises asks, can you input the seed between points as vectors? So again, I think this is similar to Octavian's question, which is like, instead of a seed, can I use a vector? And you just have to get a little bit closer to the code. So I will share a notebook that has some ways to do that. Basically, you have to convert this. You can also convert a Z into a W space using like a one-line command. So I'll make sure that people get that. All right, so the W space generator is finished. It took 1 minute and 6 seconds. So I'm just going to generate a video out of this as well. And of course, I keep doing this. I keep forgetting to name my folder correctly. Okay, so that's done. And download this. So what I'm going to try to do is actually, like, it's impossible to play these next to each other, like, together, but we can maybe scrub through them a little bit and sort of see how they're different. My other guess is that basically the way that W space works is that you convert a Z space into a W space. So basically we're taking all those seeds and we're converting the seeds into W space, and then we're interpolating in the W space between them. So because I have a lot of seeds and a small amount of frames, you might not see a lot of differences in this particular example. If you were to increase your frame count, you would see a lot more of sort of the in-between spaces between your interpolations to actually be able to see what changes and what doesn't. So there might not be huge differences in this model, although already, look at the color here. That's really interesting. I didn't even realize, I wonder if that's even real. Okay, well, anyway, let's play the W space and see. So the first thing I noticed is this feels way cleaner, like the actual, it feels less chaotic, like whereas this one felt really fast. It feels like it's flashing almost, whereas this one feels much smoother. And I think that has to do with because it's not as entangled, right? So like the entanglement adds that sort of extra layer of noise where you're getting entangled features. This feels a little bit smoother. Yeah, so that's the first thing you notice is that it's a little different. Now, if you also were to like scrub through some of these points, I'm sure we could actually find points of where like, you know, different things are altering or changing or whatever it is. So, you know, again, in this particular example, it might not be as easy to see how different W and Z space are, but like in other examples or with longer frame rates, you would actually see the differences a lot more, and they'd be a lot closer. Okay, so I'm gonna shut this. So Mateo asked a question of, if you find a nice seed, is there a way to stay near that point? Actually, Esteban asked this too yesterday, which is like, if I find an image I like and I just want to see examples around it, yes, the way you would do that is with a custom vector. I actually might try to build that maybe this week, but more likely after classes are over, just because I have a lot of other materials I have to be building. But I do think that would be a cool idea to make something like that. Basically would be like a little, like, I almost would imagine like a random generator, like a distance function. So you would generate randomly around that space to get new images that are close to that. Yeah, that's like a pretty cool idea. And I think we could definitely do something like that. Yeah, so like, there's really no way. So again, the problem, or like the nice thing about this model is that seeds are like pretty accessible, right? Like I don't need to see a 512 dimensional array to understand what I'm looking at. I can just use a seed. The problem is when you get into this like fine-tuned detail, you want access to those values, and those values are hard to get out of this in this particular way, the way this is set up. So I do have a Colab model that basically like pulls all the guts out of StyleGAN and puts it directly in Colab, and then you can actually play with stuff a little bit closer. So I will share that model. I will share that file. It's very messy. maybe I can clean it up a little bit before sending it to people. Or maybe I'll just send you all the guts because it's very, very messy. But yeah, like it's sort of like, how much access do you want to get close to the metal is sort of always the question with this stuff. Okay, so let's look at, we've done, okay, so let's look at our noise loop. So the next example here is a noise loop interpolation. So these models start in a random place and they just randomly run around the space. And it uses a thing called simplex noise. If you know what that is, it's sort of similar to Perlin noise. But the nice thing is that it ends up back where it started. So these will always be loops. What's nice about this is it creates a very fluid animation, right? So whereas that other thing where like sometimes your points are too close to each other or very far away, and you get a little bit of sort of a whiplash sort of feeling where it's like close, slow, whiplash, that sort of thing. This will feel pretty fluid because we're animating like in a continuous path and because we're not trying to match certain endpoints. The difference is that you will have very little control over what you actually generate here. You can basically set the starting point and that's it. And the saying the starting point is still a random value. And you have a little bit of control over like, so if you imagine this as a loop, if you imagine a small loop, like only covering a small space, if you imagine a big loop covering a big space, you have an option to set a diameter. So the smaller your diameter is, the closer you're gonna be to your location. The further away you are, or the bigger the diameter, the more it's gonna run through different spaces. And this is only available in Z space. And the reason for that is that basically to convert this to W space, you would get the exact same answers because you have to convert each one of those points. So this is a Z space thing only. I could do it in W space, but it'd be pretty annoying. But this still works. This is sort of visualization of essentially what you're seeing. It starts in one place, it like randomly squiggles around the screen and then comes back to where it was. All right, so let's look at that inside of Colab. So this is the noise loop interpolation. So it's pretty similar to the same commands you've seen before. The difference is that you need to pass in a different walk type. So you're gonna pass in noise loop. You are still gonna give it frames. The seed doesn't actually matter. You have to give it a seed, otherwise it throws an error. I'll try to fix that like soon. But basically you will not be using seeds. So there is no concept of like, I wanna start using this image. It just starts in a random place. So you can't really control where these things start. So I would just generate a lot of these and just sort of see what you end up with. Truncation is still important here. So you still wanna use that. Diameter. So this is like what's the width of that loop? Now this is like an analogy, not like a real thing. So if you think about that truncation space and how it's 1 or 0 or whatever, this diameter does not match that truncation space. It just matches like a concept of how big the loop could be. So if you make this larger, you will get more spaces. If you make it smaller, you'll get like a closer location of the space. And the last thing you have is what's called a start seed. So again, this seed does not match the generating images seed. It is just a starting value. But the reason that I still call it a seed is that it is a randomized starting value. But if you were to always put in these exact same parameters, you would get the exact same starting image. So that's helpful to know. Or actually you would also get you might even get the same loop. I've actually never tried that. I think you would get the same loop, but I could be wrong there. But anyway, you will definitely get the same starting value. So this is sort of a way to like control a little bit more of these noise loops, but they're pretty chaotic and you can't really control a lot of them. So let's just run this really quickly. So again, I'm gonna actually make this 100 frames. I'm gonna make the diameter a little bit smaller to manage that smaller frames just because I don't wanna spend 5 minutes generating images, but let's just run this. Come here, bug. Come on, say hi to everybody again. Yeah, come on. I have her, like, she will not yell at me for about 30 minutes and then she yells at me again. So I have to hold her so she doesn't yell. All right, so while this generates, are there any other questions? Yeah, so so Emily asked why diameter is not within truncation space. So basically, it's because I'm just using that diameter to generate a noise loop. And if you're familiar with using 2D noise or 3D noise, in order to have it loop, you need to feed it a diameter. So basically, like that diameter function actually controls the distance you're generating with the noise loop. So it's purely conceptual. It has nothing to do with sort of the actual latent space, if that makes sense. Okay, so this finished. Let's generate a video from this. This time I'm not going to screw up and create the wrong value here, but let me make sure that this is right. It is step and it is step. Cool. Okay, so let's run this. Also, I should say I stole that noise loop code from Dan Schiffman. So Dan Schiffman did like a really cool demo on using P5GS and Runway. So if you're interested in that, I'll link to it. But I stole a lot of the code from him to make that work. Okay, so this is now, I've now generated my video. Where is it here? I have a noise loop here, so I'm gonna download this. So in general, I would say that if you want like something that doesn't feel crazy chaotic, you want to make sure that your diameter, if you're in low frame rate, you want your diameter to be low. If you have a high frame rate, you want your diameter to be a little bit larger. But basically, if you crank your diameter down and crank your frames up, you'll get a very, very slow animation. Okay, so this is a noise loop. And that was it. So like, again, because we're in a small space, we're not seeing a ton of different samples here. And also you do sort of get a little bit of a bounce effect because of sometimes of how the space working, but also sometimes of how the noise loop works. So if you ever looked at noise, it's not always consistently smooth. We probably could, we never actually built a like circular model, but we probably actually could build a circle inside of these models. That'd be interesting. Okay, anyway, for another day. But basically this is a animation. So now this is obviously very short. I could crank up my frames to get a longer video. Or I could, you know, crank up my diameter to get a really fast chaotic video. If I did change, actually let's do this. So let's change this seed value to 10. And actually let's just make the diameter a little bit larger. So let's do 1.5. And we'll generate another video here. Bug doesn't like her photo taken, despite like the fact that she's on video all the time. I still only make my bone latent space. That's the one I really want. I don't think we didn't do that demo in this class, but I have a data set of my favorite cat on Instagram that's called Bone, and I need to make a latent space for that. Okay, there's no chance we're going to get to projection today, but I'll record a video of it and maybe I'll do a very quick demo of it next week. Live demos always take a little bit longer than I expect. Cool. All right, so let's generate our next video here. So we're going to name this to 4. And we're going to make our noise loop -2, and we're going to make this guy. Cool. Refresh. Okay, so let's open this one. So see already that we have a very different starting image, right? And you'll see this one moves through a lot of different images much quicker. And that's because we changed that diameter to be a little bit wider. So it goes through more samples, but it's still 100 frames. So it's still really, really fast. And you'll see it just bounces through certain things. Now, this transition here, my guess is that it might be actually through like an area that is like low sparsity or like, high sparsity, where there aren't a lot of samples within these spaces, so it kind of bounces through it quickly. If you were to run this on, say, the FFHQ model, which was trained on a ton of data, this would be pretty seamless. But with this particular model, it's probably trained on like a lot less images, so it's a little bit more sparse in certain places. But basically, this is how you build noise loops. So Esteban, you're asking like, how do you use this in your work? Sometimes this is just the end result. Like I just make this video and like this is what I share with people. You know, this is something that you see a lot of people like throw up on Instagram or turn in, like this could be, if you did this really short, say you made your diameter really small, this is only 4 seconds. So like you could turn this into a GIF pretty easily. And then you could throw it up on Giphy and then people could like share it. So maybe with like a cat, you could have like a weird cat GIF that you can then share over Twitter and whatnot. So how you use these things is like pretty much up to you. Remember that you also get the frames from these. So like if you wanted to just take the frames and maybe do stuff like either prints or other things with it, you could. Any number of this like pieces are available to you. Usually what I do is in like gallery displays, I'll like actually set this to be like, I'll generate like, you know, 10 minutes of video or 10 minutes of frames, download those, and then I've got a very, very slow moving video that is almost more like ambient. So you have to play a lot with the frame rates and like the spaces and that sort of thing before you find like what really works for you. But essentially this is a way to sort of generate these spaces. Cool, so I have one more thing to talk about before we look at homework and then before we jump on to any questions that people have. Okay, so where am I now? Okay, so mixing. So again, remembering that all of these places are, all these locations are just vectors in space. We can actually start to do stuff like adding and subtracting them. This is where it gets pretty funky and weird. Again, this like kind of makes sense, but doesn't in some ways. So if you're familiar with vector math, it'll make sense. This is way to think about it. So, okay, so let's say I have two vectors here in space, right? So I've got the yellow vector and the pink vector, and I want to add them together. If you've ever done vector math, you know that the way to do that is it's not just going to represent like the middle space between here, but actually you have to take the vectors from both of these, and then you add the vectors. So like I'm actually going to add the yellow vector to the pink vector, and I'm actually going to end up over here. Now what's pretty funky about this is that you actually end up in like a pretty different area, but it ends up feeling like a mix of these two. So this is actually the new place that we're adding. When we add these two together, we actually get this spot. So there is a command inside of this model that allows you to add images together, right? So if you look at the top here, so along the top are our seed values, and on the left here are additional seed values. And what you're seeing is sort of a grid where you add, in this case, you're adding this face and this face together. And you see it's keeping the glasses, but it's sort of changing the hair, it's changing the background. It's surprising changing the shirt color, which I'm like kind of shocked that it reads shirt colors as a feature. But essentially what you're doing is you're adding things together to create these feature maps. So again, like it's kind of funny how little of a difference this one makes, right? Like this face is like pretty prominent, but it's just adding, you know, like maybe a little bit of coloration, it seems like. There's almost nothing changed in this one. And then if you look at this one, it's similar. Like, so this one is, there's probably some very strong, so again, when we think about strong, we have vectors, like where the math is like this skin tone or whatever feature is determining skin tone or hair color might be cranked all the way to 1 or all the way to -1. So it has a strong effect on these images, right? So in this case, this person's skin tone becomes a little more olive, and all the hair features become darker. Similarly, like this one, like, so I think is interesting here is you can kind of see like what has the most weight to it when you add these images together, right? This image is very clearly like it is weighted toward children. So when you add a child plus this woman, you get dark hair, but it retains sort of the woman-like, or it retains the childlike features. So this is something you can run. I'll run it really quickly inside of Colab. You can run this on your own models as well. It is not always as clear what is happening in your own models compared to like this face feature. So I tend to run this stuff on faces for a demo, but let's look at it with Leah's stuff and just see what happens. So back over here, we'll go over to our table of contents and we'll go to mixing seeds. So there is a file here called mixing seeds. You're still gonna use your run generator. And the difference is you're gonna pass in style mixing example, and then you pass in a network. And then what you do is you pass in row seeds and column seeds. So I believe that translates to these are row seeds and these are column seeds. So when you run this, and you also need to pass a truncation, when you run this value, this might take a little bit longer. I don't actually know how long this takes to run. Okay, so while this was running, Kynan, you asked, how do you avoid those non-smooth bumps you mentioned the most? That is a very hard thing to do. I would probably recommend that you actually use just the linear interpolation in W space. That is going to avoid the bumps the most. Again, remember that it's like a smooth surface, so it's like gonna have more smoother places. And I'd probably actually say, Adam, I know you and I have talked about this too, is I would probably actually just do linear interpolations from one seed to another seed, and then do it again from that, the second seed to a third seed. So you control more of the spaces. And then I would bring those into After Effects or some editing thing and actually try to make the feeling of it very, very smooth. It is very hard to do with a lot of these things, but like, it's not clear. And this is sort of the downside of using things like code, is code doesn't think about visually smooth stuff like we do. It thinks about spatially smooth stuff. So that's sort of a challenge. Okay, so this has been finished. This is finished generating. So if I come over to my results folder and I refresh, you'll see I have a style mixing example. You would think you could show this grid video or this grid image inside of Colab. I actually found that it kept crashing Colab. This is a very, very large image. So we're gonna download this. It might take me a minute. So maybe while this downloads, because it is like a 40 or 50 megabyte image, yeah, 40 megabytes, this is gonna take a little bit of time. Maybe while this downloads, I will quickly go over our homework, and then that way if people need to head out, they can do so. So I'm gonna skip projection and maybe talk about it very briefly next week. And I'll record a video to sort of show how it works. But essentially projection is this fun thing where you put a real image into your latent space, and then you try to find the location of where that space is inside of your StyleGAN model. So in this case, I'm trying to find, what's his name? I am blanking on his name. Harrison Ford inside of the StyleGAN model. And you'll see it like takes forever to really get to a place of where it like finds a like bad B version of Harrison Ford. So I'll do a video for that. I'll talk about next week. Your homework is obviously to finish training. And I guess by finish, I mean like, it'd be good if you like kept working on your training, so you could actually do the next thing, which is to make some animations. So make some images, animate truncations, play with these values, and then interpolate these images in ways you find fun, and then share them to Slack, share them to Instagram, put them on Twitter, at me and Leah, so we can share them as well. So hopefully this week is like generating some fun images and having fun with things and finishing up your just finish your training and whatnot for your model. Octavian, your question is, can you get the vectors from projection? And yes, you can. That's in this demo that I'll show, and I'll record a video to show you how to do that. Cool, let's see if this is downloaded yet. It is not, we're not even halfway there. Okay, so we're a couple minutes over time. I will share this image in a minute, but you can also run the Colab and like see it on your own work. What questions do people have about everything they've seen or everything they want to talk about? We're here for questions now. Adam, go ahead.
I know you can do this somehow, but I found it a bit confusing. How do you, like, I know it's the same in Google, Google Drive and everything. Like, how do you reset this to the first time you got it? Like, a couple of times I've made mistakes. I know that in the same way you can edit history in Google Docs, you can edit history in here. So I just like, sometimes I'll screw up and I'll like put in the wrong code somewhere, and I just want to get to the very, like the first time I touched it and then work from there again.
Yeah, that's a good question. I actually don't know. Usually executed code history. Usually what I do is, so whenever I open a notebook, usually I can't edit someone else's notebook, so I just make a copy. And then I go back to their old notebook if I want to. One thing I did notice that I think is both nice and also kind of chaotic is that Command Z is on a per cell basis. So you might think that like, oh, you can just like click anywhere and hit Command Z and it'll go back from where you were. But Command Z is actually on in a per cell. So like you have to click back into the cell and hit Command Z in that cell. So it can be a little hard to actually track that stuff. But yeah, I generally recommend making lots of copies of your files, which is how I end up with a total mess of like spaghetti things all over the place. Yeah.
I got into some weird mode where it was an editing mode with two of them beside each other and like a history. So
that's probably the diff. Yeah, it's probably diffing. Maybe.
Yeah.
Let's see. Yeah.
No, or yeah, and then but it also showed a history on the side, and then
okay.
I was able to restore, but I like it was just really confusing. I just wondered if there was an easy way to go back as opposed to like going back to the original research paper and making another copy or something.
Yeah, no, I mean, unfortunately, like Colab is a pretty new product. And I think it's a pretty small team that works on it. So it's not like other big public Google projects where it seems like very well thought out. There's definitely some rough edges in Colab, yeah. Okay, so while people generate more questions, let's look at this grid here. Okay, so here is a grid of Leah's images, and along the top here, you'll see a sample of images, and on the left, you'll see another sample, and you can sort of see what happens when you add these two together. So, like, this is pretty strongly showing this sky blue background. So even when you add other images together, it keeps the sky blue. It also looks like the actual structure of the shape is pretty strong. This one's fun and kind of chaotic. I wonder what the hell's going on there. But this is fun. So there's two things. You can download the individual images that these produce. The problem is that at least right now, you cannot get the vectors out of these. I might try to change that in the near future, but for the moment, you can just get images. You can't get the vectors out of these. So you couldn't say like, I love this one and I want to get to it. What you could do is you could take that image, you could project it back into your space, and your projection will be pretty much this image. It'll find this image again. You can take the vector out of that and then animate using that vector. That's a hacky end around, but it would work. Moises, go ahead.
And as far as with the starting seed images, can you input them? Maybe I'm assuming that's like a different Colab example.
What are you asking to do? Sorry, I'm not sure I understand.
Like if you have specific seeds you want to mix.
Oh yeah, that's in this notebook. So over here, when you actually feed it these row seeds, you actually feed it seeds here. So row seeds and column seeds. So you can actually feed it your individual seeds from these images.
And like, let's say it'd be like my mom and my dad. Like, could it like?
Oh, so projection is a little different. So yes, you could give it photos of your mom and your dad, and then get those vectors out. Now the problem is you probably couldn't mix those vectors here, or like you'd have to like dig into some of the background code to actually be able to do that. But you could. It's probably just an addition process. So you actually just would add one vector to another vector, and what you get in the middle is actually like what would be the combined version. Or I guess it's actually averaging two vectors, isn't it? Anyway, my math, I'm not the best at math. I think that would be averaging. If you were to add the two, you would actually just get something different. But anyway, yeah. Esteban, go for it.
How do you get one of the images that you already mixed? Like, how do you pick one, and how do you, instead of having that sample?
Yeah, so you'll see what this ends up, so that grid, which is what, this guy? So I could read across. So like, these are my column seeds, right? So let's look at the column seeds here. So we have 4 column seeds. This is 55. So this one is 55. So let's say I want this image. So this one is 55 and this one is 85, right? So it's 55 and 85. So in the folder here, you'll have images that are like just sort of like, it gives you the mix, right? So it's 85, 55. So it actually would download this file. And I'm fairly confident that that's going to be this image. So you can get the individual images out of this. It does produce them. Let's look at this. Let's see. Yeah. What else is questions? Go for it, Martin.
I was wondering if anyone's tried, if anyone's training from scratch and how long, you know, how much you can get with your $300 of credits if you're going to go from scratch. Just because I was planning to use that, the landscape model, which is broken.
Yeah. You probably won't get too far on $300 of credits because it takes an extra 2 or 3 days just to get out of sort of the noisy realm of early training. So if you can, I would recommend rotating your images and using one of the other models. It actually doesn't matter. It's no different. It just like, you have to undo that process when you actually generate your images and generate the video afterward. That will save you money and it will probably save you a little bit of time, but not too much. Yeah, it's just sort of one of the downsides of that model not really working, which is unfortunate. But I'd probably would recommend that over trying to train from scratch, unless you want to spend a lot of money. Yeah. I did also mention, so there is, I mentioned this on the Slack channel, but there is a service called Vast. And Vast is basically like, well, it's literally says it here. It says it's GPU sharing economy. So you can basically, this is people who have their own GPUs. They rent them to individuals. So basically you are like peer-to-peer renting GPUs. If you want to do more training and you don't want to like spend a ton of money on GCP or don't want to build your own machine just yet, you can rent using Vast. I find the prices are about half the cost of GCP or AWS. Now it comes a little bit more of a burden of having to like figure out how to make your own things. Like actually right now I'm noticing that, oh, okay. I have a video on how all this works, but basically like if you wanted to find a 16 gigabyte GPU, you need to go over here and you need to go GPU RAM, like less than 15. And you'll see it looks like there is one model or one person is renting a 24 gigabyte GPU, which is pretty nice. That can get you a pretty like good resolution at 55 cents an hour. So remember that the V100 is, or the P100 that we're training off of is like, this is like over half of that price. And it's probably a better GPU too. So like you can find good deals on Vast. Thing is, you'll need to know a little bit more about setting stuff up in a command line interface. You probably could run the same commands that that images. Yeah, so like it is possible. And this will save you some money. For about 6 months, I used Vast almost exclusively. There's some downsides to it. It can be, people's servers can get shut off and then you might lose your work. So you have to be like very careful about saving and backing up your work. But you can do it. So yeah, it's a possibility. So Octavian, you mentioned that you got like 256 images, you got good faces in a day or two. That's also partially because you were training at 256. So basically the smaller your images are, the faster it will train. So yeah, 256 will train very quickly compared to a 1024, which is like 2 scales larger, which means it's like component wise is like 2x as long. So like if this took you 1 to 2 days, it'll take someone 4 to 6 days to get theirs working on a bigger model. Esteban, go for it.
Do you have a video on how to set up these? And also, what about the copyrights for your images and your models if you upload your stuff into these machines?
Well, I mean, so from a privacy standpoint, these are containerized. So like someone can't just go in and grab your files. I mean, maybe they could, but like these people don't really care about art. Like they're selling their GPU to like make money. So I have like 0.001% belief that they're going to like try to steal your work off a server they're using. So yeah, I wouldn't worry about that too much. Emily, you could raise your hand. Yeah, go for it.
Yeah, this is going to be hyper specific to my project, but
yeah, of course.
So I've been training that 512 model from scratch because I guess there wasn't a pre-trained 512 thing to transfer from. What I was hoping ultimately to do with that data set of like right now it's like blind contour sketches only.
Yeah.
mix it with, I'd been thinking originally like that Flickr data set, but I assume that's not 512. So I'm just wondering if you have any recommendations for like the best way to mix that. I was also thinking that like, if it was going to do transfer learning, that I could just like grab some of the early like pickles from that sort of transfer learning space. But given that I'm in this situation, training from scratch, I wonder if you have any other recommendations.
Yeah, so I mean, well, so the thing about doing transfer or mixed model training is that actually all you need is the data set. So that you don't add pickles, you add you train a new, so basically you'll take your last pickle or like whatever your finished pickle is from your blind contours, and then you'll take another data set and you'll train that data set on the new off of the new pickle or off the old pickle. So you need access to the data set, not a pickle. So what you have to do is you'll have to convert whatever data set you're using to 512 so that you can train off that.
Okay, so I could literally still take that Flickr one and just like 512.
Yep, crop it all to 512 and then you can actually train on top of each other. The other thing I would say is like, if you do make a 512 model, like I would love to talk to you because I would like to get access to that. So in case other people want to train 512s, we could train off yours.
For sure, yeah.
Okay, awesome, great, thanks. Who else has questions? Esteban always has questions. I love it.
Yeah, thank you for answering.
No.
We have a video to do the best.
Yeah, so I have a video that walks you through how to like set up Vast or just like how to pick a machine. What I'm seeing right now is that, so the problem with Vast is that it's a sharing thing. So like yesterday or maybe the day before, there were like a number of 16 gigabyte GPUs available. What I'm noticing today is that is not the case. There's only one available. So you kind of have to like know when to rent it and know when not to. And like I personally I was probably renting this exact GPU for like 3 months. I never let it go. And I just kept like paying Vast more and more money to make sure I kept this. So I would say like, if you're not super technical, Vast is going to be a tough sell because you have to know a lot of stuff about servers and that sort of thing. For you, I would still recommend Colab. I still think Colab is the best bet for you. Even though it's annoying that you're gonna have to like reset it every like couple hours or every 12 hours or so. But I do have a video on that. That video on how to like set it up on Colab is gonna be like pretty like straightforward. You will run into a lot of technical issues on Vast. And if you aren't familiar with server technology, like it is gonna get hairy quickly. So I just like maybe recommend like avoiding that for the moment. But you're almost there. You're expanding your command line knowledge pretty quickly. So maybe you just want to watch some videos on setting up servers and then you could actually access this. Octavian, yeah, go for it.
Yeah, so in one of your Slack channels, you mentioned about buying used GPUs, like an M40 NVIDIA card, which is reasonably priced at about $300. But my question is, how much time will you actually spend on making your machine and like really on the hardware part and installing all the software? Because now the thing I struggled most with was basically installing the right CUDA version and stuff like that. So
yeah, so I was planning to talk about this in the last week of class. Like if you really, really, really get into this and you want to build your own model or you want to build your own hardware for this, you can do it. And me and some friends have found some cheap ways to get like used GPUs. But it is a challenge. It is a commitment. So like what I've generally been telling people is like, if you're generating like StyleGAN models or doing machine learning, like, and you're running your machine for, let's say 24/7 for like 6 months, it's probably time to buy a machine. If you're dabbling in it and just building stuff like say, once every couple months, rent something. It's just going to save you money. It's going to save you hassle. So I just built my own GPU server. I've now bought I think I'm on 6 GPUs now that I own. And that is probably an investment of like $6,000 to $7,000. And that is all using used pieces and used parts. And it is like a huge commitment, but like literally I have been running this stuff 24/7 for almost a year now. And when you do the cost analysis, it makes sense.
and
yeah,
what kind of what kind of issues do you run into? Is it
it's
software
price.
mostly, or
It's you now have to like learn about how to keep your machine cool. Like cooling is a huge issue. So if you've built like a gaming rig before or anything like that, it's probably like not too far off from that. But for me, like this was a huge
mining?
thing.
I did some
Yeah,
mining.
so it's very similar to mining. It's like you have to keep your machine cool. You have to like manage everything. Like especially installing CUDA. Like generally, like the first time I get CUDA installed, it takes me a day to just get everything installed and set up the right way. And like I Google like endlessly, and I think I know what I'm doing with this stuff, and it's still hard. So it is definitely a commitment. I do not recommend it unless you are like very, very, very serious about what you're doing. I'm going to answer Moises' question really quickly, and then Adam, you can go ahead. So Moises asked, like, do you have a recommendation for learning server technology, like subcategories or search for a course? I don't really. One thing is if you are okay burning some cash, is just to rent a VAST server and learn by failing. I'm also not like really like I'm not a backend person. So maybe I know maybe Caitlin or some other folks are like good at AWS and other things here. You might just want to like go through some of those and see what's up. In general, for a lot of these things, you can install like, so VAST comes with Docker containers. So you can install like a pretty decent system and it should work out the box. Thing is, you still need to install, yeah, it's like DevOps. Yeah, so it's like you still need to install Anaconda. You still need to get your like Git repo installed and that sort of thing. If you know how to write bash scripts, like bash scripts will save you a ton of time. I'll probably make my VAST bash scripts public, although they're a little bit out of date, but if you want to dig in and just sort of see how they work, they can. I've sort of switched off VAST now that I have my own machines. But yeah, I have some bash scripts on how to just get everything set up. It's usually a little finicky just because like some versions are using older versions of CUDA that need to get updated. Some versions are using the wrong version of TensorFlow, like that sort of thing. But yeah, there is, you also have to know a lot about like how to keep your machine updated and like running with the newest installs, that sort of thing. So yeah. Yeah, so Kyle, like, so like another thing is like there are servers that come pre-installed with deep learning stuff. So like AWS has some, GCP, which is what we set up, does have their own. And then like I usually recommend like Paperspace for folks who are new to this whole world, because Paperspace has like a built-in deep learning setup that you can get up and running. So I do sort of like those. All of them have it's basically the difference between like, do you want to spend a lot of money to have it built for you, or do you want to like spend less money and have to do some of your own work, is basically the balance. So Paperspace, AWS, like these things will have like very nice systems set up for you, but they're going to be expensive. Whereas VAST is pretty cheap, but you're kind of on your own in a lot of places. Yeah, Amazon is very expensive. I don't actually know why Amazon charges so much for their public stuff. Amazon is easily the highest priced out of all of them, especially compared like even GCP is cheaper. Maybe that's because like they're all competing with AWS, but AWS is super expensive. Any more questions from anybody? Adam, oh, sorry, I forgot about you. Yeah, go for it.
So I know you haven't gone into projection specifically, but I just because of where I'm at with my model, I'd like to do a projection with it, because if I can't find what I'm looking for, then I might rebuild my model from scratch a little differently.
Yeah.
So given that, and I've used your previous notebook, if I want to do the most deep dive into projection and time and isn't an issue, is there any settings that I would do? Because I'm trying to like, I'm using briefly, I don't know, did you see that PDF I sent you? Like I'm taking a data set of an artist's work and then an image that's probably a fake. And I'm trying to find if I can find that image in this data set. So I want to do a really thorough search of it before I decide if I go and retrain from scratch.
Cool. Yeah. So inside this Python or the Colab notebook that Lee and I are going to share, at the bottom here is a section on projection. And really quickly for you, there's one setting that you will want to set. So this will be the line of where like you can edit. So basically this is actually where we're going to start to pull in some of the guts from StyleGAN directly into Colab, so we have access to some of the closer stuff. The thing you're going to want to set here is project.numSteps. And this is the number of iterations that it takes to search for it. So basically the way that projection works is it sticks the image in, sticks it in at the center of your latent space, and then it determines how different it is from the image that's right there. So basically what it does is it slowly moves closer and closer to where it wants to be. If you crank this to like 4,000, it will take forever, but it will try to move as close as possible to where it needs to be. So that's probably what I recommend for you. Now there's still some randomness where it might not really get there, but it will get as close as possible to where it should be. So if you run that multiple times, it'll actually give you a good idea of whether that image is in the data set.
Okay, and also the that GUI interface you showed us a couple weeks ago, do you think, is that using the mixing seeds? Do you think that's like what we're seeing there?
So I'm gonna try to get that up and running for next week or maybe the week after. I definitely I wanna experiment with it. So I wanna teach you guys to experiment with it too. It actually uses, Moises had asked at the beginning of class about PCA or TSNE. It actually uses PCA. So what it does, and Leah talked about this a little bit, is it's a way to compress that 512 dimensions into a lower dimensional space. So the idea being that what you get out of a high dimension space is lots of like tiny detailed features. Using PCA, the assumption is that it will give you just the big features by compressing the space down. So what it's doing is actually looking at that. So it's saying, and especially in FFHQ, like with the face model, like what are the big features? What are the things that cause the biggest changes, right? So it could be skin tone, it could be hair color, it could be the position of your face, right? Left to right, that sort of thing. So it basically does that work for you. And that's why I want to see if I can get that up and running rather quickly. I've looked at it briefly, and like you kind of have to convert your data set and do some other things with it. It's like, will probably not be a like quick demo, but if I can get it running, I would love to share how to do that for people, because I think it would be really helpful for you to see in your own models what the data set sees as the big features. I think that'd be really helpful for everyone to understand. So I want to get that running, but essentially use these PCA to compress these spaces. Yeah.
Oh, and I was just going to show you this one other weird thing I did, which is it? So I did the in-painting. So I did the in-painting.
Oh shit!
With my Zoom view this morning before I sat down for the meeting. So you can switch back between here to that. And then I just rendered out quick videos, and this is just a zoom out and back. So
oh, cool.
Yeah, just a funny little thing. I assume there's probably someone with code could do it a little bit, like make their own Colab that would do it a little faster than what I did. But yeah, I just thought it was a funny thing. I was trying to do it in a 3D model. It was taking too long, and this is way easier. So
cool. That's awesome. You can make all of any Zoom hangout you're on, you make people really sick and like feel like they have seasickness or whatever. Yeah.
Yeah.
Awesome.
Derek, I had a question about upsampling an image. I know you did a data set tools demo once, and you used gigapixel AI for that, I believe. Yeah. Is there a lot? So a lot of the images that I'm finding are really small, and I wanted to probably bump them up. Is there a lot of downsides to doing that, like bringing them from a smaller resolution to like 1024?
Yeah, so for folks not aware, like we're talking about super resolution. Super resolution is a way of basically, it's a machine learning model that is trained on the difference between a small low resolution image and a high resolution image. So there's two things to know about super resolution. One is it is better than Photoshop. So if you are used to taking an image in Photoshop and scaling it up using whatever like Photoshop image size tools, it will get you better than that. Like hands down, it will be better than that. The downside is that it's not that much better. So I actually find gigapixel is hands down the best, because gigapixel has been trained on very high quality photography. So again, this gets to like data sets. Most of the examples of super resolution in the wild have been trained on pretty shitty images, like grabbed from Flickr or grabbed from whatever. Gigapixel actually went out to photographers and trained the data like using really high-end photography. So you'll get the best results out of that. But I also, in that list of Colab notebooks, I have a bunch of super resolution notebooks. So I'd actually recommend like actually just running through some of those and trying them with your images and seeing what you get. My other recommendation is that you upsample in batches of 2x. So most models have like a 2x, a 3x, a 4x, whatever. And you'll want to try to jump from like 256 directly to 1024. My recommendation is actually go to 512 and then 1024. I find that you keep some of the detail better in those examples. In terms of using that for StyleGAN, I don't know. It's like, again, it's better than Photoshop. So if you really want high res stuff, you should do it. I will say that there are models that are 256 by 256 in NVIDIA's fork. So if you just want to train on, like I know, I don't know, is Octavian still here? Octavian might have left, but I know Octavian he did a 256 by 256 model. You could train at that size and also up-res your outputs from StyleGAN. It's sort of a mix of like, it's like, what is it? Half dozen or 6 of one or half dozen of the other. It's like it's maybe the same one thing, but you could try it. Yeah. And there are a bunch of different sort of like, super resolution is like a big field where lots of people are doing different things. I just personally find that like none of them are really that much better than anything I've seen else in the wild. Usually what I find is certain models work better for certain images and other models work better for other images because of their training data set. So yeah, I guess we're trying, but I don't know if it really leads to like perfect results, right? It's like AI is like, everyone's like, oh, AI is the future. And it's like, you try these things and you're like, it's slightly better than like everything else, but like, it's not really like perfect. So like, it's not really like the end, you know, it's not really going to change the world too dramatically just yet.
Where can we find those 256 by 256 from the NVIDIA
Yeah, so
repo?
actually if you go, hold on, let me share my screen real quick and I'll just show you. So if you go to, so actually if you go to the StyleGAN model that I have, because I didn't alter the README, you can just go through the README. So if you go through here, you'll see this section here. So this section here is all additional materials about this model. So there's a paper here, there's a video here, there's other things. Right here are the networks. So you'll see that they have a couple networks here that you could train off of. So there is a 1024, that's one we train off of, that's FFHQ. There's a car model that is 512 by 384. There's a cat model at 256, there's a church model, and a horse model at 256. So you could, if you click here, I think these are just on Drive. Oh, interesting. Did they lock their models? Maybe. Oh, well, here's the cool thing is they give you the ID, right? So if you use GDown, you can actually just use GDown and download those models directly. So you can actually just grab the ID from this and download it. I think that should work. Somewhere they've made these publicly available, so if you wanted to get them, you could. But that's generally, yeah. So like, there's also, so actually that Justin Pinkney, this guy, yeah. So the guy who did those latent space interpolations also has a repository here called Awesome Pre-Trained StyleGAN Models. So he has a bunch of pre-trained models and resolutions. So actually, shit, you know what? I bet you there's a 512 by 512 in here. Maybe not. Yes, there is. Emily, we could have grabbed this. You could have trained off of anime faces. You maybe actually want to do that now. But anyway, I didn't even think about this when we were talking about it. Oh, there's also WikiArt. So shit, yes, we should be training off these. So anyway, there's a bunch of other models here. So if you want to do transfer learning or like the mixed model training off of these, you can. You can also, like if you are, when you're done with your model, if you want to upload this to yours, or upload this, or like let him know, or let me know and I can let him know. He just has a repository of all these. So there's a bunch of cool ones. There's a butterfly one. There's a lot of cool ones in here. But again, the resolution is important because you can only train off of that. Someone else has made a notebook that actually a script that it supposedly can do cropping on these. So you could take a 1024 by 1024 model and crop down to 512. I've seen that there's some issues with that, but that may be something I look at between now and like the next time I teach this class. Basically, you guys are all my guinea pigs. I'm learning all the things that people want to do, and then I'm gonna like for the next class, it's gonna be even better. So sorry, but like you also like all those videos will be up on YouTube, and you'll be able to get them and watch them. But yeah, so like I'm learning all the things that I should be doing with this class with y'all, and like I'll make it better for the next one. But basically, like there is a place here where you can download some other pre-trained models if you are interested. And I assume they just link out to like, yeah, there's a download link. So like if you can want to train on Pokemon. Also, if you just want to play with these in terms of generating latent spaces, most people like are cool with like, most of people are pretty open with you like playing with the stuff, as long as like when you share it to Twitter or Instagram, whatever, you like give them credit. So. Oh, okay, interesting. So most of these are on Runway if you want to test them. Yeah, I haven't really talked about Runway in this class, but like Runway is also another option if you want to do some training. Runway can do training in their model. It has to be a square image, but you can do StyleGAN training in Runway. The upside to Runway is that it's super fast. I think what they do is they spin up 8 GPUs behind the scenes. So you can train a StyleGAN2 model in 1024 by 1024 in like 8 hours or like 6 hours. But it's going to cost you. It's going to cost you like 40 or 50 bucks to do that. So the cost probably balances out in the end, but you could always use Runway if you want to. If you want to get like very quick examples, I have a video on how to do training within Runway, and actually my next Runway class is going to be about that. So like if people want the video from that, it'll be like 2 hours of how to train in Runway. I'm happy to share that with people, but just know that like the cost is sort of pretty high over there, and you can't do fine tuning of like, I want to turn off mirroring. Like mirroring's on by default in there. There's other things that are turned on by default that you can't really control. So this class is a little bit more about having control, but like realizing that it's a little bit more annoying. But Runway is going to be much more about like sort of being, you can do stuff fast, but so it's good for sketches, but you won't necessarily have as much control. Moises, go ahead.
Yeah, actually, this just reminded me because I had asked about an example where somebody was talking, and
yeah.
How would that work? Like if you want to go through latent space, like stay within the same character and talk?
Yeah. Okay, so that model is called first order motion or whatever, something like that. And it's accessible in Runway. So if you want to grab it and play with it in Runway, the thing that I think you have to do is you have to give it a static image. So it takes video from whatever your input is and it applies it to a static image. So like to do that plus StyleGAN, you'd have to like produce that multiple times. Like basically what you would do is you would interpolate your output and then you would run that same video on the same output. And then you would have to like dump it into After Effects or some editing suite and like basically do like a shearing where like you just take the individual frames as it animates. It'd be cool as hell to see, but like it would be probably somewhat chaotic. It might not be as smooth as we would think it would be. I'm going to paste this link in the chat just to make sure everyone has it. I'll make sure it gets added to our notes as well, but just in case you need it now.
Yep, I also just linked it to the class page.
Awesome.
And also just posted notes for class.
Leah, as always, thank you. Cool. So if you have more questions, let's, we're like at 45 minutes, so I feel like it's time. Everyone needs a break. So why don't we call it a day? And if you have questions, hit me or Leah up in Slack. I would also say like, I've loved everyone like asking me and Leah DMs directly, but feel free to also ask in the Slack channel. Like I know there are some people who are much better at backend than I am. So like if you have AWS or like just server questions about like how would I write a script or like something to do this, there are people in this class that could probably help you way better than me. Not to put too much work on their shoulders, but in case you have questions, they might be able to give you a quick answer that I cannot. So next week we'll look at projection. I will try to record a video between now and that class, and then we'll look at some advanced stuff. I don't know exactly what we're going to cover yet, in part because I need to do it this week to find out. But we'll do some advanced stuff next week, which will be pretty fun. And as always, you're always welcome to ask me questions about training or about, inference, like this stuff as we go forward. Like, I'm not expecting everyone to stay directly in line with what I'm teaching. It's more just like, I want to throw, like you have 5 weeks with me, so I want to throw as much information at you as I can. But I recognize that people have different schedules or some weeks go crazy at work and like you're behind. So please feel free to catch up and like ask me earlier questions in Slack as you're catching up. All right. Thank you, everybody. And I'll see you next week. Have a good rest of your weekend.